In this lesson, you will learn about the architectural components of the IPsec VPN and how to set up a Dialup IPsec VPN. In this lesson, you will explore the following topics: IPsec Introduction, IKE Phase 1 and IKE Phase 2, Dialup IPsec VPN, Best Practices and VPN Logs. After completing this section, you should be able to describe the benefits of IPsec VPN, be familiar with the IPsec protocol, understand how IPsec works. By demonstrating competence in IPsec basics, you will be able to understand IPsec concepts and benefits. What is IPsec? When should you use it? IPsec is a vendor-neutral standard set of protocols that is used to join two physically distinct LANs. The LANs are joined as if they were a single logical network, despite being separated by the Internet. In theory, IPsec does support null encryption. That is, you can make VPNs that don't encrypt traffic. IPsec also supports null data integrity. But does that provide any advantages over plain traffic? No. No one can trust traffic that may have had an attack injected by an attacker. Rarely do people want data sent by an unknown person. Most people also want private network data, such as credit card transactions and medical records, to remain private. So in reality, regardless of vendor, IPsec VPNs almost always have settings for three important benefits: authentication, to verify the identity of both ends; data integrity, or HMAC, to prove that encapsulated data has not been tampered with as it crosses a potentially hostile network; confidentiality or encryption, to make sure that only the intended recipient can read the message. If you're passing your VPN through firewalls, it helps to know which protocols to allow. IPsec is a suite of separate protocols. It includes Internet Key Exchange, IKE. IKE is used to authenticate peers, exchange keys, and negotiate the encryption and checksums that will be used. Essentially, it is the control channel. Authentication Header, AH. AH contains the authentication header, the checksums that verify the integrity of the data. Encapsulation Security Payload, ESP. ESP is the encapsulated security payload, the encrypted payload, essentially the data channel. So if you need to pass IPsec traffic through a firewall, remember allowing just one protocol or port number is usually not enough. Note that the IPsec RFC mentions AH. However, AH does not offer encryption, an important benefit. So AH is not used by FortiGate. As a result, you don't need to allow IP Protocol 51. To make a VPN, you must configure matching settings on both ends, whether the VPN is between two FortiGate devices, a FortiGate and Forticlient, or a third-party device and a FortiGate. If the settings don't match, tunnel setup will fail. IPsec provides services at the IP network layer. During the tunnel establishment, both ends negotiate the encryption and authentication algorithms to use. After the tunnel has been negotiated and is up, data is encrypted and encapsulated into ESP packets. What's encapsulated? It depends on the mode. IPsec can operate in two modes: transport mode and tunnel mode. Transport mode directly encapsulates and protects the fourth layer, transport and above. The original IP header is not protected, and no additional IP header is added. Tunnel mode is a true tunnel. The whole IP packet is encapsulated, and a new IP header is added at the beginning. After the IPsec packet reaches the remote LAN and is unwrapped, the original packet can continue on its journey. Note that after you remove the VPN-related headers, a transport mode packet can't be transmitted any further. It has no second IP header inside, so it's not routable. For that reason, this mode is usually only used for end-to-end or client-to-end VPNs. In order to create an IPsec tunnel, both devices must establish their security associations, SAs, and secret keys, which are facilitated by the Internet Key Exchange (IKE) protocol. The IPsec architecture uses essays as the basis for building security functions into IPsec. An essay is simply the bundle of algorithms and parameters being used to encrypt and authenticate data traveling through the tunnel. In normal two-way traffic, this exchange is secured by a pair of essays, one for each traffic direction. Essentially, both sides of the tunnel must agree on the security rules. If both sides cannot agree on the rules for sending data and verifying each other's identity, then the tunnel will not be established. IKE uses two distinct phases, Phase 1 and Phase 2. Good job! You have now been introduced to IPsec. Next, you will learn about IKE Phase 1 and Phase 2. After completing this section, you will be able to identify and understand the phases of IKE V1. By demonstrating competence in identifying the different components of IKE, you will be able to successfully determine appropriate component selection for VPN deployment. IKE uses port UDP 500. If NAT-T is enabled in a NAT scenario, IKE uses UDP port 4500. IKE establishes an IPsec VPN tunnel. FortiGate uses IKE to negotiate with a peer and determine the security association SA. The SA defines the authentication, keys, and settings that will be used to encrypt and decrypt that peer's packets. It is based on the Internet Security Association and Key Management Protocol, ISA-KMP. IKE defines two phases. Each IPsec SA negotiated during Phase 2 is direction-specific. So in two-way traffic, there are two SAs per Phase 2. For Phase 1, there are two possible negotiation modes, main mode and aggressive mode. Phase 2 only has one mode, quick mode. Phase 1 takes place when each endpoint of the tunnel, the initiator and the responder, connects and begins to set up the VPN. When the endpoints first connect, the channel is not secure. An attacker in the middle could intercept unencrypted keys. Neither endpoint has a strong guarantee of the other's identity, so how can they exchange sensitive private keys? They can't. First, both endpoints have to create a secure tunnel. They'll use this secure tunnel to protect strong authentication and negotiate the real keys for the tunnel later. Now you'll examine how Phase 1 works. In Phase 1, peers say hello and create an SA that defines a secure channel. The SA is called the IKE SA and is bidirectional. In IKE V1, there are two possible modes in which the SA negotiation can take place. Main mode, aggressive mode. Settings must agree, otherwise Phase 1 will fail. Each side wouldn't be able to decrypt or authenticate traffic from the other. At the end of Phase 1, the negotiated IKE SA is used to negotiate the Diffie-Hellman DH keys that will be used in Phase 2. This slide shows the operation of main mode, in which 6 packets are exchanged. First, the client initiates by proposing that the tunnel will use one or more security policies. The responder selects which security policy it agrees to use and replies. Then, the initiator sends its key. The responder replies with its own key. Finally, the initiator sends its peer ID and hash payload, and the responder replies in the same way. In main mode, the responder cannot identify the initiator by its peer ID. This is because the first packet does not contain the peer ID. So the source IP address is used as one of the criteria for identifying the peer. This method works well for site-to-site VPNs, point-to-point VPNs, because the responder knows the IP address of each peer. So the responder is aware of which security policies to propose for each case. This mode also works well for a responder that has only one dial-up VPN. In this case, the responder does not need to identify the peer. There is only one set of security policies to use for all of them. However, this method might not work well for a responder that has multiple dial-up VPNs. In this case, the responder might need to identify the initiator with something other than the source IP address because the peer IP addresses are unknown and can change. Without that information, the responder might not know which dial-up VPN each initiator belongs to or which security policies apply. Now you'll examine aggressive mode negotiation. In aggressive mode, only 3 packets are exchanged. First, the client initiates by suggesting a security policy and providing its key and peer ID. The responder replies with the same information plus a hash. Finally, the initiator sends its hash payload. The first packet contains the initiator's peer ID. Therefore, the responder can use this ID, not only the source IP address, to identify who the peer is and which security policy to use. This is the best solution for responders that have multiple dial-up VPNs. Diffie-Hellman uses the public key that both ends know, plus a mathematical factor called a nonce in order to generate a common private key. This is crucial. With Diffie-Hellman, even if an attacker can listen into the messages containing the public keys, they cannot determine the secret key. The new private key is used to calculate additional keys for symmetric encryption and authentication. The ESP protocol usually has problems crossing devices that are performing NAT. One of the reasons is that ESP does not have port numbers, like TCP and UDP do, to differentiate traffic from one tunnel or another. To solve this, NAT Transversal (NATT) was added to the IPsec specifications. When NAT-T is enabled on both ends, peers can detect any NAT device along the path. If NAT is found, then the following occurs. Both Phase 2 and remaining Phase 1 packets change to UDP port 4500. Both ends encapsulate ESP within UDP port 4500. So if you have 2 FortiGate devices that are behind, for example an ISP modem that has NAT, you will probably need to enable this setting. When the NAT traversal setting is set to forced, UDP port 4500 is always used, even when there is no NAT device along the path. After Phase 1 has established a somewhat secure channel and private keys, Phase 2 begins. Phase 2 negotiates security parameters for 2 IPsec SAs, not to be confused with the IKE SA. They are the Phase 2 SAs, not the Phase 1 SA, that ESP uses to transmit data between LANs. IKE Phase 2 does not end when ESP begins. Phase 2 periodically renegotiates cryptography to maintain security. Also, if you set perfect forward secrecy to enable, each time Phase 2 expires, FortiGate will use Diffie-Hellman to recalculate new secret keys. In this way, new keys are not derived from older keys, making it much harder for an attacker to crack the tunnel. Each Phase 1 can have multiple Phase 2s. When would this happen? For example, you may want to use different encryption keys for each subnet whose traffic is crossing the tunnel. How does FortiGate select which Phase 2 to use? By checking which quick mode selector the traffic matches. During Phase 2, you must configure a pair of settings called quick mode selectors. They identify and direct traffic to the appropriate Phase 2. In other words, they allow granular SAs. Selectors behave similarly to a firewall policy. VPN traffic must match selectors in one of the Phase 2 SAs. If it does not, the traffic is dropped. When configuring selectors, specify the source and destination IP subnet that will match each Phase 2. You can also specify the protocol number and source and destination ports for the allowed traffic. In point-to-point VPNs, such as connecting a branch office FortiGate to a headquarters FortiGate, the configuration on both sides must mirror each other. Good job! You now understand IKE Phase 1 and Phase 2. Next, you'll learn about Dialup IPsec VPN. After completing this section, you should be able to understand Dialup IPsec VPN topology, deploy a Dialup VPN between two FortiGate devices, deploy a Dialup VPN for Forticlient. By demonstrating competence in Dialup IPsec VPN configuration, you will have better understanding of deploying a Dialup VPN between FortiGates and Forticlients. Dialup VPN is used when the peer's IP address is dynamic and there is no dynamic DNS. This is often the case for branch offices and mobile VPN clients. Because a peer with a Dialup VPN does not know the other peer's IP addresses, it cannot initiate a VPN connection request. Dialup VPN is used when you don't know where the remote peer will be connecting from, such as a traveling employee with Forticlient on their laptop, or a FortiGate device acting as Dialup client for a remote office. One Dialup VPN configuration on your FortiGate can be used for multiple IPsec tunnels from many remote offices or users. This is where the alternate name, point to multipoint, comes from. Remember that in Dialup, the client's IP is dynamic, so FortiGate can predict where it will be. This means FortiGate cannot initiate the VPN. Only the remote peer can. Now you will configure point to multipoint called Dialup VPN on the GUI. The settings that you must configure are as follows: a Phase 1, at least one Phase 2, firewall policies, if required, static routes or a dynamic routing protocol. You'll start by configuring the Phase 1 for the Dialup server. The remote gateway setting must be set to Dialup user. If the Dialup server contains multiple Dialup VPNs, select Aggressive as the mode. The use of peer IDs is required. Next, you'll look at the Dialup client Phase 1. First, specify whether the Dialup server for this Dialup client is using static IP or dynamic DNS. If the Dialup server has multiple Dialup VPNs, you must set the mode to Aggressive. Then, in the local ID, you must enter the name that this Dialup client will use to identify itself to the Dialup server. This ID must match the one configured on the Dialup server. Usually, the local source quick mode selector in the Dialup server is set to the Dialup server's subnet. The remote destination quick mode selector in the Dialup server is usually set to 0.0.0.0/0 to match all Dialup client subnets. In the case of the quick mode selectors in the Dialup client, the local address must be the Dialup client subnet. The remote quick mode selector in the Dialup client is usually the Dialup server subnet. Quick mode selectors for point-to-point multipoint do not need to mirror each other. There are usually two policies on each FortiGate to allow and inspect the traffic coming from and going to the IPsec virtual interface. Two firewall policies for the Dialup VPN server. Two firewall policies for the Dialup VPN client. The interface doesn't match a WAN interface. It matches the virtual interface, which in this example is named toRemote. The Dialup server will add a static route dynamically to this subnet immediately after the VPN is established. That way you don't need to manually configure the Dialup server FortiGate with all of the static routes for each Dialup client FortiGate. A static route to the Dialup server's subnet is not dynamically added in the Dialup client when the tunnel comes up. This route must be added to the configuration. Now you'll configure the IPsec Dialup client to FortiGate. The settings that you must configure are as follows: Phase 1. Phase 2 configuration will be the same as for the Dialup server FortiGate you configured earlier. Firewall policies configuration will be the same as for the Dialup server FortiGate you configured earlier. Routes will be added dynamically for the FortiGate and Forticlient devices for both sides immediately after the VPN is established. You will demonstrate this in the labs for Dialup IPsec VPN. You'll start by configuring the Phase 1 for the Dialup server. The Dialup server configuration for Forticlient is more or less the same as you reviewed earlier for the Dialup server for FortiGate as the client, with a few added options. The remote gateway setting must be set to Dialup user. If the Dialup server contains multiple Dialup VPNs, select Aggressive as the mode. The use of peer IDs is required. To strengthen authentication, you can enable XAuth. The Dialup server FortiGate will use the Enable as Server setting. Each Forticlient or Dialup client FortiGate will use Enable as Client. If you enable XAuth on the Dialup server, you must enable XAuth on the Dialup client too, and configure the username and password. Additionally, you should enable the NAT traversal if your Dialup clients are mobile Dialup users, because they are usually behind NAT at airport terminals, home routers, and hotel firewalls. If Dialup clients are mobile users, such as Forticlient users, you will probably enable and configure Mode Config on the Dialup server's Phase 1. This is for an IPsec extension called IKE Mode Configuration. Why? It's usually not practical to allocate static IPs to each laptop and mobile phone. IKE Mode Configuration is an alternative. Like DHCP, Mode Config automatically configures the client's network settings. As with DHCP, you define a range for the pool of VPN virtual IPs and the DNS settings. Another Phase 1 option is XAuth. Phase 1 supports two types of authentication: pre-shared keys and digital certificates. The XAuth extension to IPsec forces remote users to authenticate additionally with their credentials, username and password. So added additional authentication packets are exchanged if you enable it. What is the benefit? Stronger authentication. There are two ways of configuring the list of users authorized to connect to the VPN. One is by selecting a specific user group that contains those users. When you use this method, you need to configure more than one Dialup VPN if you want to apply different access policies, depending on the user group. This also means using aggressive mode and peer IDs. The other way to configure the list of authorized VPN users is by selecting the option Inherit from Policy. With this setting, FortiGate authorizes all users that belong to any user group assigned to any of the firewall policies that allow the VPN traffic. In this example, there are two firewall policies for the VPN traffic. One allows the traffic from the user group Administrator. The other policy allows the traffic from the user group Training. In this case, all users that belong to either Administrator or Training can connect to the VPN. The advantage of this method is that you can have different access policies for different user groups and keep only one Dialup VPN in the configuration. If your clients are only Forticlient, there's a simpler alternative to configure the Dialup server. Use the VPN wizard. It will use route-based VPN and will enable IKE Mode Config, XAuth, and other appropriate settings. Good job! You now understand Dialup IPsec VPN. Next, you'll learn some best practices and analyze IPsec VPN logs. After completing this section, you should be able to use best practices for Dialup IPsec deployments, analyze VPN logs in VPN Monitor. By demonstrating competence in best practices and logs, you will be able to apply best practices and use basic techniques to analyze and monitor VPN logs. In circumstances where multiple remote Dialup VPN tunnels exist, each tunnel must have a peer ID set. Make sure the Forticlient version is compatible with the FortiGate OS version. If your FortiGate unit is behind a NAT device, such as a router, configure port forwarding for UDP ports 500 and 4500. Make sure hardware acceleration is enabled for IPsec best performance. Check IPsec VPN maximum transmission unit MTU size. A 1500 byte MTU is going to exceed the overhead of the ESP header, including the additional IP header and so on. The FortiGate sets an IPsec tunnel maximum transmission unit MTU of 1436 for 3 DES SHA1 and an MTU of 1412 for AES 128 SHA1. You can verify this using the CLI command diagnose VPN tunnel list. This indicates that the FortiGate allocates 64 bytes of overhead for 3 DES SHA1 and 88 bytes for AES 128 SHA1, which is the difference if you subtract this MTU from a typical Ethernet MTU of 1500 bytes. You can configure FortiGate to log VPN events. For IPsec VPNs, Phase 1 and Phase 2 authentication and encryption events are logged. For information about how to interpret log messages, see https://docs.fortinet.com. To view IPsec VPN event logs, click Log and Report VPN Events. The sample log indicates negotiation failure for Phase 2. The sample log is for Dialup IPsec VPN user student. This mobile user is connected using Forticlient. Log message indicates user is authenticated successfully and tunnel is established. This slide shows another example of the Dialup IPsec VPN log in which the user student failed authentication and therefore the tunnel was not established. The user entered an incorrect password. You can monitor which Dialup IPsec VPN users are connected in the IPsec Monitor section. This shows the names of all Dialup IPsec VPN users that are currently connected to FortiGate and their IP addresses. Congratulations, you have completed this lesson. Now you will review the objectives covered in this lesson. This lesson covered the following objectives. Describe the benefits of IPsec VPN. Be familiar with the IPsec protocol. Understand how IPsec works. Identify and understand the phases of IKE v1. Understand Dialup IPsec VPN topology. Deploy a Dialup VPN between two FortiGate devices. Deploy a Dialup VPN for Forticlient. Use best practices for Dialup IPsec deployments. Analyzing VPN logs and VPN Monitor.